We're going to introduce a new data type, and it's called the character data type. I usually, when I see it, like when I say integer, I say int because we write int. For the character data type, we use char, char. And char has a byte that assigns a numeric value that is looked up by the computer and turns it into a character. When we assign a character into the type, so we have, if we look, we have char and then the identifier letter, the assignment, and then in single quotes and a single character. And there are two encoding types, ASCII2 and Unicode. ASCII2 is Roman alphabet centric, and Unicode contains characters for other languages. And in the appendix of the book, there's a breakdown of the ASCII code and some of the Unicode characters. We'll look at a program that will show us some displays of the possible characters that we can get from this. Notice to do Unicode, we use a /u and then in 4 hexadecimal digits. And hexadecimal is 0 through F. There are 16 digits in a hexadecimal. So F represents the number 15. The reason Unicode is done in hexadecimal is because each digit then represents a particular bit break. And so the /U0041 puts in a Unicode character into letter, and numchar Unicode puts in a number. You can use increment and decrement operators on char variables, character variables, because it'll move forward or backwards through the character set. So let's look at these examples, and we'll do letter and numchar, and we'll look at A4. We'll also look at the Unicode version and the decimal version. So let's come back over here to Eclipse. I'll go back into my sandbox, and we'll close this out, and we'll say char, and we'll say a letter, and we'll assign the capital letter A. And then we will print letter. And so when we run this, we get the character A out. Now, what we want to be able to do is to look at the Unicode version of A. So we'll use /U0041, and we'll print this out. And notice we also get the character A. So this is a numerical encoding in hexadecimal for the letter A. Well, hexadecimal, that's 1 in the ones place and 4 in the 16th place, which I believe translates to the decimal 65. And so all 3 of those representations represent the letter A in the computer memory. When you put the single quotes in it, Java takes the bits for 65 or 41 in hexadecimal and stores them in the byte pattern for letter A. Now we can use a pre-increment. And so we're going to start with the letter A, but it advances to B. So increment and decrements work with characters. And we've already kind of been using the character class. Scanner uses characters inside of strings, which we'll look at later in this chapter. And it reads the characters and converts them into other values. There are some interesting things about character classes. So let me come through here. And we'll redo this in Unicode. One. And we'll compare it I'll make this letter 1 and 2. And what we'll do is we'll come up 0, 6, 1. We'll come up a byte pattern, and we'll print letter 1 plus letter 2. We'll print letter 1 and letter 2. Do it at 2 separate lines. Sorry if I'm talking quietly today. I've adjusted the microphones and trying to get it so that I don't have to shout into these. So notice letter 1 is a capital A and letter 2 is a lowercase a. Shifting this particular bit pattern up by 32, which is a bit shift, changes uppercase to lowercase. So from a binary aspect on this, changing from a lowercase letter to an uppercase letter is adding an AND statement or a 1 or a bit add to a particular bit position. This was developed early on in computers so that the shifting of a character related to a shifting of a bit, and the shift key could be turned into turning on or off a bit. And so uppercase A, you have this lower number. Notice here in this part of the hexadecimal, and if I come up 2, well, 2 in the 16th place is 32. And 32 is an even bit, a bit divider that we put in. And so the design of characters, and if we look at the character chart, made sense for how the computer had to translate. Let's come back to our lecture slide here. And so we saw increment moving our way through the alphabet. Now, the Unicode format has the ability to print other characters. So notice, for example, here they're showing an output with Unicode in Greek. So 3B1 is alpha in Greek, 3B2 is beta. Now, I'm going to look at Eclipse here, and we're going to use U03B1 to print some Greek letters. Let's come back to Eclipse. And we'll come into here. I'm going to comment out character 2, and I'll comment out character 2 here. And we'll do 3B1. And we'll run this. We'll do this as a print line. And notice we get alpha in Greek. And so if I wanted to go through my Greek alphabet, beta would be 3B2. Get the beta, lowercase beta. And gamma, 3B3. In fact, I'm going to introduce a statement here. What I'm going to do is I'm going to just print out, I'm going to introduce a thing called for. We'll make a for statement here. And we'll print out 30 characters. Now you don't have to worry about the for statement. I'm going to take char back here. I'm doing this for a display purpose here. And what I will do is I won't use a new line. We'll print these all on an individual line. What I might want to do is, so this is going to print 30 characters. This should fit on one line. And let's see if it works here. Oh, I have an error because I did letter, not letter 1. Let's try that again. And so I started with gamma, and it did delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, c, omicron, pi, rho. There's a sigma, not tau, epsilon, phi, chi, c, omega. And so omega is the ending there. If I go back and make this start at alpha and run this, I get my Greek alphabet. If I remember correctly, I think my Greek alphabet. And then I've got the characters after the Greek alphabet. So notice how special character sets have translations within the characters. I think the Greek alphabet traditionally has 25. Let's see, yeah, so if we do 24, yeah, and there we have an entire Greek alphabet. Now, we'll get more into for statements later on, chapter 5. But I just wanted to show how Unicode has different characters in it. In fact, we can explore the different Unicode characters and just randomly jump deeper into it. And we have other character sets. If I randomly jump deeper into it, let's try 800. I'll notice nothing printed out here. Not all character sets are loaded into your font system. And so sometimes you can print a Unicode character and it won't display anything. Let's drop down and see if I get anything in the lower runs. And so there are other special characters in here. I'll put a link up in the references onto the different Unicode characters that we're able to use. And I think I'll leave this showing off the Greek characters. And so there's our Greek alphabet. So Unicode became a very powerful extension to what was just a Western-centered keyboard set that computers initially had. There are some important places. The numbers 0 through 9 are 48 to 57 in decimal, which is Unicode 30 to 39. The characters for A to Z capitalized are 65 to 90, or 0041 to 005A. And notice the shifting I talked about from lowercase a to Z, 97 to 122. Now, another thing that we've started to use, I've pointed out into some programs people had, is special characters or escape sequences, which are special Unicode characters. We can do the backspace, which is /B. We can do tabs, which are, depending on how your output is displayed, it's a spacing over a certain amount. A line feed, which creates a new line. a form feed, which moves the line up one, a carriage return, which takes it to the beginning of a line. To print a backslash, we put the slash in front of it. And to print a double quote, we put a slash in front of it. And these last two are really important. There's certain characters that get used by Java as commands. The slash is being used for any of these escape sequences. So we call the slash an escape. When it's going to print, it sees the escape sequence and then reads the character after it and prints special things to the screen. So if you needed to print a backslash, you would put two slashes. Because our strings are in quotes, if you need to print a quote, you have to escape the string. Same thing with percentages. If you want to print the percent sign, you need to do /%. Now, line feed, form feed, and carriage return comes back from the original printers. And actually the typewriter. If you were typing on a typewriter and you got to the end of the line, you would have to push the carriage, which was what held the paper, all the way back to the beginning of the line and advance a new line. So these were two separate things. The form feed would move the paper up for the next line, and a carriage return would return where the character was printed to the beginning of the line. The line feed does all of this in one. It moves up a line, it moves down to the next line, and starts printing at the beginning of the line. Let's look at some of these escape sequences inside of a program. So again, I'm in my sandbox, so I'm going to get rid of these here. And I'm going to use system.out.print. So print normally does not print a new line. So this is printing. And if I come down again and do another system.out.print, this is more printing. If I run these, it didn't create a new line. Well, the escape sequence for a new line is /n. And notice how it added a new line. Well, let's look at some other things we can do. Let's use a tab. So we'll /t as a tab. And so we get tabbing. What were some other of the statements we could use? Well, let's try using a backspace. So notice I get a question mark here, and Eclipse is not processing a backspace. Depending on the terminal that you use, this will move the character back and start printing again, which would overwrite the G. Because Eclipse has a font interpreter on it, it doesn't have a font for a backspace. If you're running this in the command line instead of inside of Eclipse, you would have the last character overwritten. And let's look at printing some special characters that we might have an issue with. Let's say I wanted this in quotes. So I'm going to escape a quote. I'm going to escape a quote. And notice I'm able to get quotation marks in. If I want the backslash itself, I'll put two backslashes on either side of more here. So I'm using the escape sequence saying I need to see a backslash. And I see the backslash. We also can get the percent sign. Whoops. Which is needed inside of printf statements. And notice it's not recognizing the escape sequence. I get an error within Java. So Java has some particular escape sequences. Now, if I were to put a printf in here, which we're going to study in more detail, clear this out. Oh, I have a typo. So if I have a printf, the percent sign gets used to drop in a variable. So if I want to print a percent sign, we use a representation very similar to escaping percent. So recognize that there are certain characters that, when using different print commands, are commands themselves. And if you want to print them to the screen, you'll either have to use a escape and a list of escape characters, or a doubling of the sign, as in the printf, to get a percent. So Java has to interpret the characters that we're using programmatically for it to display the results. Now here is the ASCII character set in a decimal. And so you have the first 2 digits of the decimal, and then in the last. So we said A was at 65, so I come down to 6 and over to 5, and there's A. Now notice this is blocked and there's a gap in it. And the pattern between A, capital A, and lowercase a is kind of broken. But if we look at it in hexadecimal, where we have the first hexadecimal digit, 0 through 7, and the second hexadecimal digit, we can see that 4A starts here, 6A starts here. And we can see the bit pattern in the actual encoding. And null is completely empty. Bell, or 07, is the system bell, which would actually ring a sound. Again, this goes back to typewriters. Typewriters would have an end-of-line bell on them. Now, characters themselves can be cast. Integer I equals A will cast the same as giving the character code for A, which was, if we go back to our ASCII table here, lowercase a was at 97. And character C equals 97 will turn the number into the character. So Java has casting automatically, and to the computer it is an integer. It is a byte. And Java will transfer back and forth between them. Now we can test characters. So we can compare if a character has a less than, greater than, or equal to value. So here, this is a number. This starts at, go back to our ASCII table here as I jump back to it. Capital A is decimal 65, and capital Z is decimal 90. So this if statement says if your 65 greater than or equal to 65 and less than or equal to 90, you're going to be an uppercase letter. And then we do an else if that compares to the lowercase numerical values. And then in here, it looks to see if you're between 0 and 9. Because internally in the computer, these are turned into numbers, we can do greater than or less than, because the numbers, and I'm going to jump back to the character set again here, because these numbers have positional value. And so you can look at 7, the character 5, 5 is less than 9, the character 5, 7. And so you have the ability to do comparisons on these based on the fact that they fall into a list and have order, especially since the alphabetical ones are subdivided. But to make this easier for us, Java has some methods that will do these comparisons. IsDigit will return a true value if it returns a digit, like 0, 1, 2, 3, 4, or 9. IsLetter returns true if it's a letter, uppercase or lowercase. IsLetterOfDigit returns true, and I think that should be IsLetterOrDigit, returns true if it is a letter or a digit. IsLowercase will let you know if it's a lowercase letter. IsUppercase will return true if it's an uppercase letter. So notice all of these is methods return true or false. They're Boolean. But 2 lowercase and 2 uppercase takes whatever the letter is and make sure that it's a lowercase letter or an uppercase letter. So let's play through all of these in our sandbox. So I'm going to use my scanner. And so I'm going to make a new scanner object. And oops. And I just need a prompt to know that I need to enter something. And then character equals input dot next. And then we have we're just going to use dot next to get the next token. And notice we get an error here. It cannot convert from a string to a character. And so we have an issue on trying to get, are we still on the screen here? On getting from a character, from an individual character from the keyboard. Next does not, our input scanner does not have the ability to get an individual character. Okay, I need to switch screens here. And so this will be a problem that we will have in dealing with trying to make menu options on it. So let's see here. Want to text equals next, input.next, next. And what we'll do is we'll say char letter equals text dot chars 0 at 0. And this should give, and we're going to study this string in about 2 little videos, but this should give me the first character. So to compare characters, we have to go through a little bit of, I called it letter, but let's just see if I can input. And so I can input a character. Now what I want to do here is I want to look at, and I'm still not able to switch the screen here. Yeah. Well, at least I can type it. I want to look at what happens if I do is digit, is letter, and so on. So we'll use the is digit, is letter form for all the character classes. And so letter dot is digit bump, 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 bump. And a character class. So character dot is digit, and we'll put in letter. And so we're gonna get our output here. So like I said, I wanted to use is digit. Notice we had to use the character class dot is digit, and then we're throwing in our character here to see if it's digit. So if I enter A, I get a false because it's not true. If I type in 3, I get true. So this is how the character classes work. And we can use these in if statements. So let's work our way through. We had is digit. Let's try is letter next. So here I'm doing character dot is letter, and I'm giving it my character. And so if I enter 3, it's false. If I enter A, it's true. If I enter capital A, it's true. So it's able to check, do I have letters, uppercase or lowercase? And let's try is letter or digit. And remember, it's typo in the book. It says letter of digit. Today is the day of typos, I guess. So 2 is true. Capital A is true. Lowercase a is true. Backslash is false. So you see, this character class gives us some power that we can do some testing. And let's go to lowercase. So let's to lowercase. And so if I type in a capital B, it prints out a lowercase b. Well, what happens if I do something that isn't lowercase? So I'll do a quotation mark. I still get a quotation mark. I do a single quote, I get a single quote. So it only converts letters to lowercase. And if I'm already lowercase, it keeps it lowercase. So these are some powerful class extensions with character dot that lets us manipulate individual characters.